Hi there, welcome back to this channel. In this video, we are going to be discussing bond polarization. Now, you see, the concept of bond polarization is a very important concept in organic chemistry because it helps us to understand how chemical reactions occur with organic compounds, how the mechanisms of the reaction and their intermediates are all, going on. Is that okay? So it helps us to understand what is going on in between in a chemical reaction. All right. So remember we talked about covalent bond. We said non-metals covalent bond. We said it is a bond that is formed between what? Non-metals. And we said co corresponds with what? The word together. That is, there is a sharing of electrons. So they share electrons, right? When non-metals form a bond, they form a covalent bond, which means this essentializes that they share electrons. All right. Now, we used a classical example, the HCl, and we said that this bond in between them basically corresponds with two electrons. Is that okay? Two electrons between hydrogen and chlorine, and they are sharing these two electrons. So that if we want to count the duplet structure of this guy, or the dual structure of hydrogen, we are going to count these two electrons. And we'll be counting the octet structure of this guy. We'll be counting 1, 2, 3, 4, 5, 6, 7, 8. So these two electrons belong to both of them because these two electrons are being shared by both of them. Now, think of it as, I want you to begin to envisage it as an electron cloud. Why? Because electrons, according to Heisenberg's uncertainty principle, Heisenberg said that it is impossible to say specifically the exact position of an electron at a particular period of time. So, but we can predict using certain numbers called quantum numbers. Quantum numbers. We can use quantum numbers to predict the relative position of a particular electron in time. Is that okay? Now, so these electrons are within a cloud of orbitals. Is that okay? Orbitals that are together, that overlap each other, and then electrons are in between that and within that cloud, and are moving around. Now, these electrons being shared by these two guys, we will count them to belong to both of them. We will count both electrons to belong to both of these guys, the hydrogen and the chlorine. Now, but there is a property that makes, even though they are sharing these electrons, there's a property that makes them have unequal sharing of electrons. There's a property that makes this sharing happen unevenly. Now you might begin to see that, of course, they are overlapping each other, and then the bonds are in between both of them. But actually, even though they overlap each other and the bond is being shared between them, because of a particular property that one of them, now if you look at this is an heterogeneous molecule. So because it is heterogeneous, they have different properties, different abilities. Now there's a property of atoms known as electronegativity. Now, what is electronegativity? Electronegativity is the ability of a particular species, atom in this case, a particular species, to draw electron towards itself, or draw electron density in this case towards itself. Is that okay? Because it has a greater pull for electron. Now, electrons are going to want to spend more time with it than this guy. Now, the classical way of thinking of this is when both of you and your friend, you are hungry, and then you are in your house, and your mother serves you food in your own house. So, but your friend is a glutton, and you are not much of an eater, but of course you're hungry on that day, maybe very hungry. But this guy is so voracious that as mommy serves the food, his hand is faster than yours. And then he's eating most of the food. He's eating most of the food. Now, At that point in time, because you are eating food, you might not be hungry. But of course, both of you are satisfying your hungers, but he is satisfying his hunger more than you are doing. Why? Because he has a greater pool for food. So in this case, this guy has a greater pool for electrons, so he's going to draw electron density towards itself higher than this guy will do. I hope that is okay. So because it has a greater pool for electron, this guy is going to gain what is known as a partial positive charge. Now, let me explain what that means. That partial positive charge means that he's feeling like he's electron deficient. Just the same way you begin to feel like I am still hungry, even when food is in front of me and I am eating. Yes, because your friend is rushing more than you, so you begin to feel uneasy. So because of that, this guy feels uneasy and gets what? A partial positive charge. A positive charge means a positive charge is electrophilic. Electrophilic means that it is tending to coordinate towards another and looking for more electrons. Isn't it that it is electron deficient? So it behaves as though it were electron deficient. So this becomes an electron deficient center, and this becomes an electron sufficient center. Hence, this guy acquires a partial negative. Notice the charges are partial. The delta plus and delta minus, they are partial charges, they are not formal charges. Now, this is the difference, that electrons are not abstracted by either of the atoms. This guy did not pull out the electron, this guy did not pull out the electron. But both of them are sharing, but there is an unequal sharing. Think of it as there was a tug of war between you and your friend on who would eat what. And then your friend has more power or just has this physical advantage over you and is able to pull more of the food to himself. And then you are feeling uneasy, feeling bad, not because you have not gotten something, but because he has gotten more than you. And that is the way I want you to envisage this. So this guy gains a partial positive, while this guy gains a partial negative. All right. Now, you see, this property is what we call polarization, bond polarization. Think of the word pole. What does pole mean? Positive and negative charge, north and south pole of magnets, north and south pole of the earth. Is that okay? So it means two ends, two opposite ends. Is that okay? So you see there are two opposite ends here. One behaving as though it was electron sufficient, electron abundant, while the other end behaving as though it were what? Electron insufficient. Now that is what bond polarization is all about. That because of electronegative differences in electronegative value, in fact, for chlorine, the electronegative value is what? 3.0. Why this guy has an electronegative value of what? 2.1. Now, and the principle is that once your electronegative value, the principle of polarization says that when the electronegative value is greater than or equal to 0.5, then the bond is what? Polar. The bond is what? Polar. And if less, the bond is non-polar. Because if less is going to be just weak van der Waals forces. But because it is greater than, if you subtract this from this, you're going to get 0.9. 0.9 is a great value, it's a relatively great value compared to this. Why? Because it has is a very great value, and because of that, it's going to have a greater pool on electron because the electronegative value is what? Higher. All right. Now, what does this bond polarization cause? Now, it has influence on some properties of the molecule, which are the solubility of the molecule. It determines the solubility of the molecule. Now, it also determines the melting and the boiling point of the molecule. Now, these guys are based on the polarity of the molecule. If it is non-polar, it's going to dissolve in non-polar solvent. Remember in our last video, we talked about like dissolving like. Is that okay? So if it is non-polar, it will dissolve in non-polar solvent. While if it is polar enough to dissolve what? Polar solvent. Is that okay? Now, also remember that the higher the polarity, the higher the melting and boiling point. How is that? Let me explain how. Now, Remember, I said in the last video that dipole, first, what causes polarity, or what is the measure of polarity? The measure of polarity is what is known as dipole moment. Dipole moment. Now, mathematically, dipole moment is basically the product of the charge separation, the positive and negative charge separation, and the distance between them. But now, dipole moment, if you have if a molecule, an atom, or a molecule rather, have a high dipole moment, it means that it's going to have a higher polarity. Is that okay? Now, in this place, if I drew my hydrogen to Cl bond, and I say this one is partial positive, this one is partial negative, the dipole moment will be drawn this way. So it's going to be drawn in the direction that goes to the side that is more electronegative. So because this guy is more electronegative, this guy is more electronegative, so our dipole moment is going to be drawn like this. These represent dipole moments. If I were to draw for the molecule of water, for example, you know water is like this. The dipole moment, this is going to be partial positive, partial negative, partial positive. You see, hydrogen is always cheated. All right. So my point is this, that this guy is going to be, the dipole moment is going to be towards it because the pool of electron is more towards oxygen. Oxygen being what? More electronegative. So dipole moment is going to go like this and like this. Is that okay? Now, I was talking about that polarity. Now, if the polarity is high, it's going to have a higher melting and boiling point. Why is it going to have a higher melting and boiling point? It means it will require more energy to break the bond. Is that okay? Now, how does that make sense? Let's make sense of that. Recall in our video that we said that once there is high polarity in this way, what will happen is this. This hydrogen will seek to coordinate to another end that can supply it oxygen. Is that okay? So because it is feeling so much electron deficient, just the same way you will feel, because your friend has cheated you, you feel like maybe stealing or doing one thing or the other to get more as much as your friend has gotten. That is what hydrogen is trying to do. But in this way, it can't steal, you know? So what it does is, it's going to look for an electron sufficient center to coordinate to. So we're going to have another hydrogen inside, for example, I give you a cylinder full of hydrogen chloride. Now, if I zoom in zillion and trillion times, this is what I'm going to emit. I'm going to emit HCl's coordinated to each other. Why? Because this guy is feeling electron deficient, and this guy, even in this place, the bond is already polarized. Why? Because this guy is more electronegative. So because this guy is electron sufficient, this guy is going to seek to coordinate to it. This guy is going to coordinate to what? Another hydrogen. Notice it's represented in dot, 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 because it is not a sharing of electron that is happening here. It's only that they are being attracted towards one another. Why? Because they are held together by this is what you call dipole-dipole interaction. And I talked about it in one of my videos. Dipole-dipole interaction. So because of this dipole-dipole interaction is what is what increases the polarity of the compound. So, for example, this guy, because his partial positive charge is bonded with this, and partial negative charge is going to coordinate to this, and like that, like that, they will keep coordinating to one another. They will keep coordinating to one another with these bonds being what? Dipole-dipole interactions, and that is why. So, because of those dipole-dipole interactions, it becomes harder to break. Is that okay? You know, we talked about the dipole-dipole interaction as being stronger than the van der Waals forces. Is that okay? So we say it was stronger than the van der Waals forces, although hydrogen bonding is stronger than it, but the dipole-dipole interaction is stronger than the van der Waals forces. So that is why the melting and boiling point is going to increase. So the more polar the solvent or the compound, the more the higher both of these properties. Now, what are the effects? The effects of bond polarization. Now, we have the inductive effect. Number 2, we have the electromeric effect. And number 3, we have the resonance effect. Resonance effect used to be called the mesomeric effect. And the 4th one is the steric effect. steric effect. Now, in further videos, we are going to discuss all of these effects, starting with the inductive effect. See you in that video. Make sure that you please subscribe to this channel to help the channel grow, and make sure to share this content with others who might need it. And God bless you as you do so in the name of Jesus. And that is it for board polarization.